Welcome again to Math 800 Pre-Algebra. Today we are doing section 5.5, dividing signed decimal numbers. Our objectives: 1. To divide a decimal by an integer. 2. To divide a number by a decimal. 3. To estimate the answer when dividing decimals. And 4. To use the order of operations with decimals. Dividing a decimal number by an integer. First, write the decimal point in the quotient, that's your answer, that goes on top, directly above the decimal point in the dividend. Then divide as if both numbers were whole numbers. Lastly, check your signs. If both numbers have the same sign, your quotient or answer is positive. If they have different signs, the quotient is negative. So basically, bring your decimals straight up and then divide like normal. Example: find the quotient of 21.93 divided by negative 3. The 21.93 is the dividend, the negative 3 is our divisor. For now, we're going to ignore the signs and just focus on the division of the values, 21.93 divided by 3. Note that we have a positive divided by a negative, so our final answer will be negative. Be careful. 21.93 divided by 3 could also be written as the fraction 21.93 over 3. Division and fractions are basically the exact same thing. In both cases, when you go to do the long division, the second number, or the bottom number, goes on the outside, and the first number, or top number, goes on the inside. It has nothing to do with the size of the numbers. It has to do with where they are located. So the first number and the top number are the dividend. They go inside, and the second number or bottom number is the divisor. They go outside. Be very, very careful with that. Now we will get into the actual long division. What we're going to do with the decimal is just bring it straight up and then ignore it. We're going to divide like normal. However, it is very important that you have everything in the correct place value. If your place values get off, your decimal will be in the wrong spot in your final answer. One way to make sure that you have all your place values lined up is to do long division on graph paper. Write each number inside a square, then draw in the division symbol, draw the decimals straight up, and then make sure everything you do stays lined up in the proper column. So we would start 3 going into 2. 3 can't go into 2. If you would like to, you can write a 0 above the 2 to indicate that it didn't work. However, we typically don't write zeros that are on the left of a number. We only really care about the zeros that are in the middle. Since 3 can't go into 2, now we're going to look at 21. Since we're working with 21, everything we write needs to be lined up in this column right here. So 3 goes into 21 7 times. I'm going to write the 7 directly above the 1. It is critical that you have numbers in the proper location. So since we're doing 21, everything will be lined up with the 1. 7 times 3 is 21, again lined up with the 1. Subtract and we get 0. Then you'll drop the next number down, which is 9. And now everything we do has to be in this column. 3 goes into 9 3 times. We write it in that column. 3 times 3 is 9. Subtract and you get 0. Now we're in the next column. Drop down the 3. 3 goes into 3 one time. Again, notice everything is in this column. 1 times 3 is 3. Subtract and we get 0. We are now done because two things have happened. The first is that we no longer have any digits, and the second is that we have a remainder of 0. You need both of these things to happen in order to be done with your problem. So our answer are the digits 7.31. However, you can always check to see if you got the right digits by multiplying. 7.31 times 3 should equal 21.93, and it does. But remember, our answer wasn't a positive and a positive. It was a negative because we had a positive 21.93 divided by a negative 3. So our final answer is negative 7.31. Again, different signs, negative answer. There's your answer. Another example. Find the quotient of 470.7 divided by 9. The second number is your divisor, that goes on the outside, and the first number is the dividend, that goes on the inside. The decimal point stays lined up, and we just go through the process. 9 goes into 47 5 times. 5 times 9 is 45. Subtract and get 2. Drop down the 0. 9 goes into 22 times. 2 times 9 is 18. Subtract and get a 2. Drop down the 7. 9 goes into 27 3 times. 3 times 9 is 27. Subtract that and get 0. Again, we are done because We have no more digits left, and we got a 0 at the end. You can check this by multiplying. 5.23 times 9 should give you 470.7, but be careful, 470.7 is not your answer. 52.3 is your answer. This is just a check. As far as points go, I do not need to see your check. However, it is a good idea, particularly on an exam, to go back through after you have finished all of the problems to check your answers with these kind of things. Another example. Divide 1.5 by 8. Use multiplying to check the quotient. Remember, our goal is to keep dividing until we get a remainder of 0 and you have no more digits. In some cases, as in this case, we're going to have to write in additional zeros to make that happen. So if we start the problem, the 8 goes on the outside because we're dividing by 8, so that's on the outside. 1.5 is on the inside. This is what I mean about being careful about where the numbers go. It's not bigger or smaller. In this case, it's divide 1.5 by 8, so 1.5 is our dividend, 8 is our divisor. Carry the decimal up. 8 goes into 15 one time. 1 times 8 is 8. We subtract and get 7. But the problem is, even though we have no more digits, we didn't get a remainder of 0. So we're going to have to do some more work with this. All digits have been used, but we don't have that 0 yet. So what we're going to do, and again I'm going to demonstrate this one on graph paper. This is where we are so far. Is I'm going to start filling in zeros. Remember, 1.5 is the same as 1.50 or 1.500 and so on. So I'm just going to add in a 0, drop that down, and continue this process. You are going to continue until either you get a remainder of 0 or you get a repeating pattern. 8 goes into 70 8 times. 8 times 8 is 64. Subtract and get 6. We don't have a remainder of 0, so add another 0. Drop that down. 8 goes into 60 7 times. 7 times 8 is 56. Subtract that and get 4. We still don't have a remainder of 0, so add another 0. Drop it down. 8 goes into 40 5 times. 5 times 8 is 40. We subtract and get 0. In general, you should not be going much beyond 4 decimal places. I will give you answers that either terminate or end after 4 decimal places or will repeat by now. Or, in the few cases where that doesn't happen, read the directions carefully. Sometimes they tell you to round, and so you don't need to keep on going forever. We can check our answer. Oh yep, so 3 zeros were needed in order to get that remainder of 0. You can check by multiplying. We get the right inside number, so that means our answer of 0.1875 was correct. Another example. Divide 4.7 by 3. Notice, as we did this, we had to fill in zeros, and we keep getting 20 minus 18, 20 minus 18, 20 minus 18, and no matter how many times we add a 0, we're going to keep getting a remainder of 2. We've added 3 zeros so far, but we still don't have a remainder of 0. No matter what happens, we're going to keep getting that remainder of 2 over and over again. That's because there's no new numbers. We're going to keep bringing down the 0, we're going to keep subtracting, we're going to keep getting 2, and it will never end. This is an example of a repeating decimal. There are 2 ways to write repeating decimals. The first is with a dot, dot, dot. The second is with a bar over the number that's repeating. Notice the bar is only over the 6. The 1 and the 5 are not repeating, so they do not have a bar over them. This is my preferred way to write repeating decimals. When you get a repeating decimal, write it with the bar. In some cases, they will ask you to round repeating decimals. So in this case, we're rounding to the nearest thousandth. Make sure you read your directions very carefully. We can check with the rounded answer. Note, we cannot check with the repeating answer. We have to round it in order to check. And when you check, it's not going to be exact. We get 4.701 instead of 4.7. That's because a rounded answer is not the same answer. It's close, just like this is close to 4.7, but it is not the same, so it will not be exact.